there, this is Mrs. Often, and I'm happy to be here talking to you today about an introduction to matrices. First, we want to define what exactly a matrix is. So an M by N, that little X sign is read as by, matrix is a rectangular array of numbers. And that rectangular array is arranged in rows and columns. You'll notice the rows start at 1 and go down until row M. The columns also start at 1 and they go over until N. So it has M rows and N columns. The entries of the matrix are the numbers, and the numbers are shown here as A, I, J. The subscripts tell us what row and column each entry is in. So A with a subscript of 21 means that it's the entry in row 2, column 1. A with a subscript of 13 tells us it's in row 1, column 3. The order of a matrix tells us the size of the matrix. An M by N matrix has M rows, has N columns, and it has order M by N. If M and N are equal to each other, then the matrix is a square matrix. On our previous slide, these entries that are in that have the same row and column number, so like A11, A22, we have A33, these would be on what's called the main diagonal of the matrix. It goes right across. Only square matrices have this main diagonal. So one of the most important things that we can do is to be able to identify the order of a matrix. So looking at this matrix A, I can see that it is 2 rows by 3 columns. Its order is 2 by 3. This matrix has 2 rows but just 1 column, so it is 2 by 1. This matrix has 3 rows and 2 columns. It is a 3 by 2 matrix. Notice that A and C look very similar to each other, but A is a 2 by 3 matrix and C is a 3 by 2 matrix. It's important to know the difference between these. One of the skills we'll be using in this section is writing and using a matrix for a given system of equations. Usually we want to use matrices if we have systems that have 3 or more variables. It can really make solving those systems of equations much easier to do, and we'll work on this using the graphing calculators. So here's my system of 3 equations in 3 variables. 2x plus 3y equals 8. 2x plus y plus z equals 9. And negative y plus 2z equals 13. You'll notice that all of my variables are written in alphabetical order, and I strongly recommend that you do that with any system of equations that you have. So from this, I can produce 2 matrices. The first one is called the coefficient matrix, and it's called that because it includes just the coefficients of the unknowns. You can see my first column has the x's, 2, 2. The third row, the x entry is 0 because there's no x in the third equation. The second column is for the y's, 3, 1, negative 1. The third column is for the z's. Since there's no z in the first equation, I get a 0 right here. Then 1 and 2. Here's my augmented matrix. The augmented matrix looks exactly the same as the coefficient matrix, except that it also includes the constant terms, which appear after the equal sign. So 2 keys before you write these matrices that go with the system of equations: alphabetical order for your unknowns and isolate the constant terms on the right-hand side of the equal sign. And you'll notice this dashed line going vertically between the third and fourth columns that's telling us, hey, the coefficients end at the third column. After this dashed line, it is the constant term. So you should only have one column appearing after that dashed line. Now there's a lot of things that we can do with matrices. Really exciting. They're like numbers, but more fun. They're even more fun than vectors, I promise. So we have these elementary row operations. What are elementary row operations? These are operations that we perform on individual rows of a matrix. And when we perform them, we produce what is called a row equivalent matrix. Now this row equivalent matrix represents a system of equations that would have the same solution set as the one represented by the original matrix. There's 3 row operations. The first one of these is swap 2 rows. Now you'll see this notated as something like R1, double arrow R2. That just means swap row 1 and row 2. Where row 1 was, you're going to write the numbers from row 2. Where row 2 was, you're going to write the numbers from row 1. We can multiply a row by a scalar. So I can multiply, here I'm saying let's multiply row 1 by -3. Every single entry in row 1 will be multiplied by -3. All the other numbers in the matrix are going to stay the same. And the most complicated one is the multiply and add. So right here, I have 2R2 plus R3. This means multiply everything in row 2 by 2. Add those numbers to the corresponding entries in row 3 and write your answer in row 3. So I'm going to write here, put answer in R3. So those are our 3 elementary row operations. We're going to use them a lot. Here's an example like the ones you might see on the homework problems. So I've given you this matrix 4, 2, 3, 1, 5, 6. And I'm asking you to first swap row 1 and row 2. And once you've done that, add -4 times row 1 to row 2 and write your answer in row 2. So, after I take this matrix and I swap row 1 with row 2, I'm going to get 1, 5, 6 in my first row and 4, 2, 3 in my second row. So now I've carried out that swap of row 1 and row 2. My second thing says take this answer that I've gotten, multiply all of these values by -4, add them to what is in row 2, and write the answer in row 2. Row 1 is going to stay looking just the same. So just to help me with this, I usually copy the matrix and I write my numbers above it. Okay, I'm going to multiply all of these by -4. So I've got -4, -20, -24. I'm going to add these numbers to what's already in row 2 and write my answer in row 2. Remember that row 1 is going to look exactly the same. So -4 plus 4 is 0, -20 plus 2 is -18, and -24 plus 3 is -21. Okay, so now I've changed from my original matrix up here to a new matrix down here. Now what's good about this is that I can see that I'm reducing the number of larger number coefficients that I had, And I've even got a 0 in there. And you'll recall that what we were doing when we were solving systems of equations was trying to get rid of coefficients. Getting a 0 in a matrix is like eliminating a coefficient. So that's really our purpose behind the elementary row operations. So in your notes before class, I want you to write a system of 3 equations and 3 unknowns. Don't worry, we're not going to solve it. I want you to write the augmented matrix for this system. If you need to rewind the video and see what to do, that's great. Then, on that augmented matrix, I want you to perform the following 2 elementary row operations. Swap row 1 with row 2. Then, using that answer, multiply what's in row 2 by 2, add it to row 3, and write your answer in row 3. Write down the final answer that you get, because in class we're going to trade and discuss. And that's your introduction to matrices and elementary row operations.